Guys, welcome to my channel. If you're a civil engineer, please subscribe to get videos on regular basis on different engineering topic, especially civil engineering topic. And also if you are a GATE or ESE aspirant, you can subscribe it to get videos on regular basis on different topic of civil engineering subject. Okay, so today's video is related to another episode of your strength of material, and today's video we will discuss about the strain and also the effect of stress on any body. So in last videos we have seen that if any stress like this is applied on a body, how the stress are acted on different plane like this, what are the normal stress and what are the shear stress, everything. So now we will discuss what is the effect of the stress on the volume or on the dimensions of this body. Well, if any tension is applied on this body like this, it will simply elongate. Okay, so if previously the length was L, now it is L plus, let's say, delta L, due to this applied stress. Now what about this cross section, or what about this dimension? Let's say previously it was D. Okay, so now what is this? Is this more than D or less than D, or it is equal to D? Obviously from different type of different experiment, it has been observed that when the length is elongated, the cross sectional dimension reduced. Okay, so in this case it will be less than your D. And it is also observed specially by mathematician, a French mathematician called Poisson, that this reduction, or you can say unit reduction, if total reduction is, let's say, delta D for dimension D, so unit lateral reduction will be delta D divided by D. Okay, and the unit elongation, total elongation is delta L for length L. So unit elongation or strain is your delta L divided by L. Poisson observed that these two ratio, okay, so contraction in lateral direction and elongation in axial direction, that is your delta L by L, is always constant whatever may be the stress, and this constant or this ratio is known as your Poisson ratio. Clear? So what is Poisson ratio? Poisson ratio is the ratio of unit lateral contraction unit lateral contraction divided by your unit axial elongation. This is known as your Poisson ratio. And Mr. Poisson found that the value of this mu is 1 by 4, and his the basis of this finding was he was using molecular theory of structure of material. Okay, from that he find that the value of this mu is 1 by 4. In real life also, this value is almost near about 0.3 for your steel. Okay, this mu value is 0.3. Now what is the implication of this mu? Why we should learn Poisson ratio? What is the implication? If you know the Poisson ratio or mu, you can calculate the change in volume for any material if the stress is known to you. Okay, so let's see how to calculate the change in volume, or how to use your Poisson ratio in our engineering mechanics. Let's consider this object where you have applied a tensile stress. Let's say this is your sigma, and after applying this stress, previously the length was L, and now your length has become L plus delta L. Clear? So what is the new length? So new length L dash is your L plus delta L, or L into 1 plus delta L by L. And you know that this delta L by L is nothing but the strain. So L into 1 plus strain epsilon. And what about the lateral dimension? Okay, so let's say it was previously d, small d, and now it is d dash. Okay, obviously d dash is less than d, or d minus small d. Okay, so take common d, 1 minus small d by d. You have already learned that Poisson ratio is your unit lateral contraction, or small delta d divided by d. This is your unit lateral contraction divided by unit axial elongation, or delta L by L. Or from here we can calculate that this is equal to mu times delta L by L, or again delta L by L is your strain, so mu times strain. Now put here, so new lateral dimension is your d into 1 minus mu times epsilon. Clear? Now previously what was your volume? So previously volume was L multiplied with lateral dimension d. Let's say in other direction also the dimension is d, both are d. Okay, so previously it was L multiplied with d into d. This was your volume. Now what is the new volume? L dashed into d dashed into d dashed, no doubt in it. Okay, so put L dashed. L dashed is your L multiplied with 1 plus epsilon into d dash, so d square into 1 minus mu time epsilon whole square. Okay, so L d square into, this is coming as your new volume. If you simplify this, it will looks like L d square 1 plus epsilon into 1 minus 2 mu epsilon. Ignore the higher power because your epsilon is very small. Okay, that's why we ignore the higher power. And again simplify this, L d square 1 plus this minus 2 mu e minus 2 mu epsilon square. Again ignore this higher term, and it is coming as L d square 1 plus epsilon minus 2 mu epsilon. Okay, so change in volume is b dash minus b, so it is coming as L d square epsilon minus 2 mu epsilon. Again, if we want to calculate what is the unit volume change, we can simply divide this volume change by its original volume. So delta V by V is coming as your epsilon minus 2 mu epsilon, or epsilon 1 minus 2 mu. This is your unit volume change due to the applied tensile stress in one direction. Okay, so it is obvious that whenever you are applying any tension on a body, its volume will naturally increase. Okay, so delta V, or unit volume change, is always greater than 0. So from here we can say that epsilon multiplied with 1 minus 2 mu is greater than 0 always, or 1 minus 2 mu is greater than 0, or 1 is greater than 2 mu, or mu is less than 1 by 2. So the maximum value of mu, or Poisson ratio, is 0.5. Clear? Now based on this principle, let's solve a problem. What is the problem? In a body like this, let's say this is the body, you have applied a tensile force P. Okay, the cross sectional area is uniform and it is A, total length is L, and the unit weight of this material is, let's say, gamma. So you have to find total volume change in this body due to this situation. What is the total volume change, or delta V? So unit volume change you have just calculated, that delta V by V is your epsilon multiplied with 1 minus 2 mu. This is the equation of unit volume change, this one. And now the task is you have to calculate the strain. Okay, so strain due to this load, external load, is nothing but your stress by E, or stress is P by A E. So this is your strain. Clear? And what about the self weight? What is the total self weight of this body? Simply volume A L multiplied with your unit weight, that is your gamma. So this is the total weight acting on this body, or the total self weight acting on this body. And we can assume that this is acting at the center of this body. Okay, so due to this load, what is the deflection? Simply from this formula P L by AE, we can say, let's say here P is P dash, L is L dash. So P dash is your this one, A L gamma, total load. Okay, acting on this length only, as it is acting in center, so it is affecting only the half length, that is your L by 2. So it is L by 2 by AE. This is the deflection due to this self weight. Okay, and strain is nothing but deflection, unit deflection. So you have got already delta L, or delta, that is your this one. Simplify this, you will get cancel AA, and you will get gamma L square by 2E. So delta L is gamma L square by 2E divided by 1 by L, cancel L, you are getting gamma L by 2E. Okay, so for your self weight, your unit deflection or strain is coming as gamma L by 2E. Okay, so now put in this formula in place of strain, what is coming? Delta V by V is coming as 1 minus 2 mu into strain due to external load, that is your P by AE, plus due to self weight, that is your gamma L by 2E. Okay, so what is the total volume change? Delta V is equal to V multiplied with this one, V is AL. Now this is coming as P by AE plus gamma L by 2E. Again simplify it, you will get AL1 minus 2 mu by, take out this modulus of elasticity E, and you are getting P by A plus gamma L by 2. Okay, so this is the total volume change on this body due to external load P as well as due to the self weight. Okay, now let's say instead of your single direction stress, there are two directional stress. Let's consider this object. Okay, here in this direction sigma x is applied, and in this direction sigma y is applied, and you have already learned where this type of stresses occurred. Simply in a boiler, a cylindrical boiler, you know sigma x is the axial stress and the value is PD by 4T. If you don't know how to get this value, please watch my last video or the previous video, you will get the answer. And in sigma y direction, this is your root stress, the value is PD by 2T. Okay, so in this case, how we can calculate the total volume change? Okay, so consider again this object. This is sigma x, this is your sigma y. So due to, let's say there is no sigma y. Okay, so for right now there is no sigma y. Due to this sigma x, what is the strain? Epsilon x, this is sigma x by E, modulus of elasticity. Clear? And due to this sigma x, what is the contraction in y direction? You know, this is minus mu times sigma x by E. This is nothing but contraction is in y direction, this is the x direction, this is your y direction. Clear? Now apply sigma y. Let's say now there is no sigma x. Due to this sigma y, what is the change in y direction? In y direction, simply strain will be positive, that is your sigma y by modulus of elasticity. And again, due to this sigma y, in this direction there will be contraction, lateral contraction. And what is this? This is your strain in x direction and it is negative, that is mu times sigma y by E. Okay, so once this sigma x and sigma y is known to you, you can calculate what is the value of sigma x, strain in x direction and strain in y direction. Once these are calculated, again apply the same thing, just like that. This one, how to calculate unit volume change. Let's calculate it for cylinder. So previously, let's say the length of this cylinder was L and the diameter, let me draw it properly. Now I think it is quite better. Okay, so previously length was L and the diameter of the cylinder was, let's say it was T. Okay, and so volume was simply K times D square into L. K is any constant. Okay, and once you apply this stress or this sigma x and sigma y like this, what is the change in length? In length, the change is, let's say now length is L dash. This is L dash is L plus delta L. Okay, or L times 1 plus delta L by L, or L times 1 plus epsilon x, because in this direction strain is your epsilon x. Clear? And in lateral direction, let's say new dimension is, or new diameter is D dashed. This is your, let's say D plus, as here compared to this one, here you can see here only stress was applied in one direction, that's why your lateral dimension was decreased. Clear? But in this case, in both direction we have applied stress, so it is expected in lateral dimension it will also increase. So lateral dimension is D dash is equal to D plus delta D. Okay, take out D, it is 1 plus delta D by D, or D multiplied with 1 plus, what is this? This is the strain in y direction, or epsilon y. This one we have already calculated it. Okay, so it is coming as your epsilon y. Now apply the volume formula again. So new volume V dash is equal to K times L dash multiplied with D dash square, or K times L D square. For L dash we are getting this one, that is 1 plus epsilon x. For d we are getting this one, 1 plus epsilon y whole square. Okay, so again if you simplify this, you will get new volume as k l t square, neglecting all the higher powers. I am not repeating the same. You will get 1 plus epsilon x plus 2 epsilon y. Okay, so what is the unit volume change? Again, to get the unit volume change, simply delta v by v, and you will get what is the unit volume change.